Okay, so let's take a look at how we can actually get Objective-C compiled on Linux. So the first thing is to go to Docker. Here is the full URL. It's the Docker toolbox, and click on the download Mac to actually download the installer for Docker. You need to have VirtualBox installed as well to actually get it done. Once you have it, you go grab the package. I have already pre-downloaded. You can actually go through the installation process, and as you go through this, it's going to actually install Docker, and your machine will be actually ready to do the work. I've already done so I'm not going to repeat. Once this is done, if you head over to your application folder, you're going to find a Docker folder where there is a Docker Quick Start. So if you click on that, it opens up a terminal, creates a virtual machine running Linux. That virtual machine is hosted by VirtualBox, and you have all your environment set up for this terminal to be able to actually create, start, and manipulate virtual machines. Now the virtual machine we're using here is already all set up, so if I do a Docker machine, I can type Docker machine ls, and it shows me the list of virtual machine. Right now I have one running, that's default. You should have one running as well once you have done that. Note that it takes a little longer the first time because it needs to create a default Linux machine, which is usually a Ubuntu setup. Note that this is without any UI, it's all terminal-based user interface. Now, in case you grab another terminal, which is always possible, so here I pick another terminal. If I want to actually see what is going on, I can type Docker machine here as well and type the ls command, and it's going to show me which machine are running. So it works as well over there. There is a difference between the two terminals though. In this one, everything is already set up to actually talk to the Linux virtual machine and ask which containers are running over there. For that you use the docker command, and for example docker ps-a asks to give the list of machine, and here it's empty. If we try the same command here, it can't even contact the virtual machine. In order to fix that, you would have to type eval and then ask to docker machine to print the environment variable for the default machine. The default is exactly the one we see here, right? That's the default, and I ask for the environment variable for the default. Once this is done, I can repeat the docker ps, and now both terminals behave in an equivalent way. They're equally good. Great. Now that this is done, our next order of operation is to actually go grab from Docker Hub a specific machine that contains all the tools and the environment necessary to build Objective-C. I've already created that machine and it's available here. So if I type Docker images, it gives me the list of all the images, and the one we care about is the first one. The name is ldmbis gnustep, and the tag is 36. The machine is 1.7 gigabytes in size. The way to get it would be to type docker pull, then you would type ldmbis gnustep : 3.6. Now when you do that, it's going to automatically, it assumes you have an internet connection, and it's going to automatically contact the Docker Hub site and look for a machine that carries that name, find it and download it. Note that this machine only contains the tool for the compilation. They do not contain at all any code for Objective-C per se. Okay? So here I already have the machine, it's here in the images, but once you've done the docker pull, what you should see, and here I'm going to run it, but since the machine is already there, it's probably not going to do anything, is telling me, yes, my machine is up to date, and I even see the SHA-1 for the machine, it's already there, and typing docker image, as you've seen above, gives me the list of machines, and the one is over there. So I just have a local copy that I can start using. That copy is embedded inside the default VirtualBox machine. Now, to start it, the command is simply docker, then we can type run, Now there are a number of arguments. The most important one, and before I do that I'm going to move into the right place, is mounting directory from your host, which is your Mac machine, inside the Docker container to be able to actually manipulate the container and the files directly from there. So I'm going to go inside work, and I've created a Docker. So if I go cd work, I've created a directory OCP Docker, which is the normal Objective-CP setup that exists for me to work from. You'll see, for example, that in here there is now in the project a Docker file. So if I take a look at Docker file, you will see that it contains just 4 lines, and it says that it's creating, so the point of this file is the configuration for creating the actual container that we will use. By default, in Docker, when you log in your root, here I don't want to do that, I want to construct the entire software as a user. So what I'm doing is that I'm using the disk image we've just downloaded and executing a command to add a user, and here the user is my own initial, and I'm asking that it be user 1000 because that's what I'm using on my machine, and I'm adding the user to the sudo group. Then I'm saying we should log in as that user, and the work directory should be home and then the name of that user. You can of course customize the Docker file for your own taste. So for Pascal that might be home pvh, pvh, user ID 1000, etc. Right? You make the minor edit to this file to make it happen. Now that we are ready to go and create a machine, I can actually say the first command is docker build, because I want to actually build a brand new machine, and I'm going to give it a tag name, and we're going to say this is the OCP machine, for example. And what are we building? Well, we're building according to the content of the Docker file. So I'm using the Docker file, and the dash is to say take the input from the standard input, and I'm redirecting. So I hit that, and he builds an image. Now that's it. I have an image, and if I type docker images, you will see now that there is a brand new, which is called OCP, created 5 seconds ago. It's based on the GNU step machine I just discussed, and that's the one that I'm actually going to instantiate to create a container. Now to do that, it's docker run. The first important argument is -v, because I'm going to map the current working directory to home LDM, which is a path within the virtual machine, and I'm going to call it OCP for simplicity. Then it's -it because it's going to be an interactive shell that I want. I want to use the OCP machine, and then the command I wish to run inside is bin bash, so that I have a shell. So I hit that, and I get a new prompt. I'm inside home LDM, and there is a directory called OCP. Now, actually, I'm no longer in the Mac now. I'm inside the virtual machine running Linux, and I'm inside the container that I've just created running exactly all the software I need for this. So if I go inside OCP, I find everything we were expecting. I find CLO, I find the Docker file. It's everything like a normal Linux machine. Point in case, I can go check, and we see here that I have that virtual machine configured with 1 CPU. Okay, so that's the configuration I use for building. 1 CPU setup for this machine. So now to build, it's quite easy. You go inside CLO. Once you're there, there is a makefile, and all you have to do is run the makefile. So we just hit make, and it will build everything. Now, if you want to change the options, you need to edit that makefile. Now, Emacs is available also within the virtual machine, so we can fire it up. The only thing that you should worry about at this stage is the CFL variable of the make that indicates the level of debug information. So -G for debugging, and O0 for no optimization, all the way to -O2. Beyond O2, it's not quite reliable. I think that there are still some issues at O3 where some benchmarks don't work as expected, so you should stick to O2 at the maximum. Now, this makefile will do everything. It will build all the directories as well as the example application. So if I type make, it gets going, and you see that he's telling me he's building the first OR utilities and he's printing the options. So we're compiling using the views and we're combining optimize. So after that, he's going to do foundation, then the microkernel, then Objective-CP itself, then the modeling layer, the program layer, etc. So he's going to build each and every single one in turn. One thing I should have pointed out is that all the makefiles are meant to actually use gurobi 550 at the moment, and it has to be in the current working directory. We'll take a look at that afterwards. If you place it in that standard location, the makefiles will locate it perfectly fine. If you put it someplace else, then you have to edit the makefiles again to reflect the exact location where gurobi is. So it won't be much longer. He's done, he's built everything, now he's building the benchmark. And each time he's building a benchmark and copying its place in a bin directory. So all the executable will be collected in the same place. Now these are the same benchmark as we get under OS X. Most of them do take options or input files, and you have to actually copy the files in place and use the correct option if they expect them in order to actually run the benchmark. So another 30 seconds or so and we should be done. Still some warning we should clean. That's it, that's done. So now if I go in the bin directory, I have all my executable here, and to open the hostilities, let's say we pick queens 2 and we do the 8 queens version minus Q8. We run this, that's it, it runs 92 solution, the right number of choice point. So this is working fine. We can go and run Golem, say the 10 version, and here we go, it's running Golem ruler exactly as usual. I want to do progressive. I believe that the default that I'm using on OS X is Q1 and 9. And he picks that up and he runs the benchmark as expected. Magic perfect square runs as well, right? So we see that everything is behaving as expected in the build. Now we will need to add more benchmark to the collection and confirm that everybody is working as expected, but this is to do. So that's the last one I'm going to show. Okay, so everything is working clearly. Note that in this directory I did copy things like progressive.txt, slab.dat, the data files, or market DTA for market 2s, which are required by these benchmarks. So finally, last thing I wanted to show is that at the OCP level in the tree, you will see that there is a gurobi 550, which is of course a Linux version of gurobi. It's not in our repository. I placed it there for the sake of building on Linux. You need to download it and decompress it in this specific location for having everything working as expected. Do recall that when we're inside CLO, the various makefiles are going to actually have references pointing to it. So if you look at the top makefile, you don't see a reference. That's okay. Because actually the files are being set up from, the configuration are being picked up from the setup. So there is a setup.make file that contains the important configuration, and that's where you would find the location where the header files for gurobi are located. So if you again change the place where you decompress, you would have to edit this. But this is a minor tweak over everything else, and I'll try to make it user independent by saying home OCP gurobi 550. That will be another improvement to add into the mix. But that's it for actually running everything, and once we're done we can exit, and then we're back at the macOS level. Notice that if we do a docker ps, it shows that there are no container running, but if we ask ps all, it's showing me that there is one container that exists. It's based on the OCP image, and that container was created 6 minutes ago when we started this. I have an identifier for it, but if I was to redo the command docker run, it would create another copy completely independent of this one. If I want to reuse this container, the way to do it is docker start, and then you need to give the beginning of the identifier. For example, start 65C. Now once we do that, the Docker container is started. If I do a PS, you'll see that this time it no longer says exited, it says it's been up for 3 seconds, and I can connect to it by doing a docker attach, and then I need to give the container name 65C, at which point I'm again back at the prompt and I'm ready to work inside my container. Okay, so last thing that's worth noting, so now ps-a, the container is stopped, so I'm good. Note that the Docker machine is still running and consuming resource. If I do Docker machine ls, we see that the default machine is running. If you want to save on resources, you might want to stop the virtual machine. That's quite easy to do with the Docker machine command. You can say Docker machine stop default, and it will stop the machine. There is another circumstance where you want to do that. If you reboot your machine, then the virtual machine won't be running. So you would have to say Docker machine start default to actually get it started, right? So let me stop it here. And there is one more reason why you want to stop or start, is that if you are changing your networking environment. Unfortunately, when you change the networking environment, that is, for example, you disconnect your MacBook Pro and it's no longer on the wireless at home, and you go to work and you had the machine running. When you reconnect at work, you're on a different wireless, you would get a different IP, and the machine has no way of knowing for reaching out to the internet. So if you want to have internet connectivity from within the container, it's important to stop the virtual machine and restart it so that it reacquires. Terminate that. Now work OCP docker. Now let's redo that. Docker machine ls, Docker machine start default. So notice here I'm not even making use of the command that's available through here, right? I just went directly to a terminal to actually do everything. Okay, so now it did start it. So if I do an ls, the machine is there. Now to make it work and be able to reach the container, I need to again set my environment for the default machine. And now if I do a docker ps-a, surprise, I have my OCP that's up and ready to use and is available there. That's all there is to it. This should work perfectly fine, and I'm going to push the latest changes, including the Docker configuration file, to the repository. Have fun!